All right, so we all know large language models, right? LLMs. They're incredible. They're basically wizards with words. They can whip up poetry, break down super complex articles, even translate languages almost instantly. But what happens when you take these language geniuses and throw them a curveball? What if you ask them to leave the world of words behind and dive into the cold, hard world of pure numbers? Well, that's exactly what we're going to dig into. And that really is the big question here, isn't it? Can a model that's basically been trained on the entire internet's library of text actually predict the future? I'm talking about things like stock prices, or how much energy we're going to need next month, or even what the weather's going to do, all just from looking at a string of numbers. It's a pretty wild challenge when you think about it. So this is where our language genius gets into a little bit of trouble. As it turns out, just because you're a poetic genius doesn't mean you're a math whiz, not by a long shot. Okay, let's put it this way. Asking a normal LLM to forecast numbers is kind of like handing a brilliant poet, a super dense financial spreadsheet. They see the numbers on the page, sure, but do they get the story behind those numbers? The trends, the seasonal ups and downs, all the hidden patterns? Nope, they're completely missing the context. And the researchers behind this paper, the STELLA paper, they call this a fundamental deficiency. See, the old way of doing things was just, dumping raw numbers into the LLM. But that doesn't work. It fails to give the model any context, which means the LLM's most powerful tool, its amazing ability to reason, is just sitting on the bench, completely unused. So the big question is, how do you fix that? How do you bridge that gap? And this right here is where we get to the core breakthrough of the research. It's all about figuring out how to talk to the LLM in its own language, words, but about a topic it's totally clueless about, numbers. What the researchers figured out is that LLMs are missing two crucial pieces of the puzzle. First, there's what they call supplementary information. Think of this as the big picture context. Like, is this data about hourly electricity usage, or is it about daily stock prices? That context is huge. And second, there's complementary information. This is the nitty-gritty, the specific story of the data you're looking at right now, like, whoa, there was a sudden massive spike in demand right here. And this really gets to the heart of what the paper asks. It's not about trying to turn an LLM into a giant calculator. No way. It's about something much smarter. It's about translating the story of the numbers into a kind of guide, written in plain English, that the LLM can actually use to think and reason about what might happen next. So, what's their solution? Well, it's a framework called STELLA, and you can think of STELLA as the ultimate translator and guide, the key that finally unlocks the LLM's hidden talent for understanding all this time series data. And how STELLA does this is actually pretty brilliant and elegant. It's a three-step process. First, deconstruct. It takes that messy, raw data and breaks it down into its basic parts, the overall trend, any repeating seasonal patterns, and whatever's left over, the random noise. Then, step 2, translate. It turns the behavior of those parts into simple text descriptions. They call these semantic anchors. So instead of just a wavy line on a chart, the LLM gets a description like, hey, there's a strong upward trend here with a peak every week. And finally, step 3, guide. It uses these little text guides to steer the LLM's thinking, basically giving it a story to follow while it's looking at all the numbers. So what you end up with is this much, much richer conversation with the AI. These semantic anchors basically act as a perfect bridge. They translate all those hidden patterns in the numbers, the trends, the cycles, the noise, into a story that the LLM can finally understand and actually use to reason. It's like giving the AI a multi-layered map instead of just dropping it in the middle of a forest. Okay, that all sounds great in theory, but talk is cheap, right? The real question is, does it actually work? So the researchers did what any good scientist would do. They threw STELLA into the ring to go head-to-head with a bunch of other top-of-the-line forecasting models. And believe me, they did not go easy on it. STELLA was put through the ringer. It had to handle long-term forecasting, short-term forecasting. It even had to learn from just a tiny sliver of data. That's called few-shot learning. But the ultimate test, that was zero-shot learning. That's where it had to make predictions for datasets it had never, ever seen before. It's basically the equivalent of a pop quiz on a subject you didn't even know existed. Talk about pressure. So let's really zoom in on that ultimate challenge, the zero-shot forecasting, because the results were honestly staggering. STELLA didn't just win, it dominated. It just slashed the error rate. We're talking over 24% better than the average of all the other models, almost 12% better than the next best model that also used an LLM, and over 17% better than a top-tier model that was specifically built for this stuff. I mean, that is a massive, massive leap forward. And just in case that didn't sink in, check out this number. In all those different zero-shot tests, all 40 of them, STELLA wasn't just better on average. No, it was the absolute best performing model in every single one. 40 out of 40. That's a clean sweep. It just goes to show how incredibly well it can take what it's learned and apply it to totally new problems it's never seen before. And it wasn't just a fluke in the zero-shot tests either. STELLA's dominance was across the board. It beat the state-of-the-art in long-term forecasting, it swept all of the short-term tests, and it was still the top dog in most of the scenarios where it had very little data to work with. Just incredible performance all around. Okay, so what does all of this really mean? This is bigger than just one cool new model. This points to a completely new way of thinking about how we use AI for anything involving numbers. At its core, what STELLA is doing is helping the LLM make sense of chaos. It's an organizer. With those simple text prompts, the model learns how to sort the data's different pieces, the trends, the seasons, the random noise, into these neat, understandable groups. And this proves it's not just making lucky guesses. It is genuinely learning to understand the fundamental structure of the data, all because it was guided by language. And for me, the biggest takeaway from all of this is pretty profound. It suggests that the future of making AI more powerful isn't just about building bigger and bigger models, it's about building smarter communication. STELLA proves that if you can translate a hard numbers problem into a language problem, you can unlock the incredible intelligence that's already sitting right there, waiting to be used. Which leaves us with one last pretty exciting question to think about. I mean, forecasting is just one piece of the puzzle, right? What other huge, complex, number-heavy problems could we solve? Think about things like drug discovery, or climate modeling, or the chaos of financial markets. What could we achieve if we just got better at teaching our AI to understand the why behind the numbers?